out of St. Louis, Missouri. St. Louis, Missouri's regional office. And he's originally from Southwest Missouri area, but Chase spent 14 years in city and county government, GIS coordination. Prior to coming to Esri, he became an FAA certified remote pilot and started his own UAV and GIS consulting company. And now as a solutions engineer, he supports the local government team. So welcome, Chase. Thanks for joining us.
No, thank you. Can everybody see my screen?
I think so.
All right. Well, I won't waste too much time. I want to get into it because we have a lot of ground to cover in a short time to get there. So I want to thank you all for letting me present today. Like Katlynn said, I'm Chase Fisher. I'm a solution engineer for state and local government. Today we're going to talk about drones, particularly drones using site scan, and then also how to use artificial intelligence and machine learning in relation to that drone imagery. So drones provide a new perspective. So they're safer, lower cost, and easy to use. And anytime an organization, no matter if it's local government or not, encompasses these values, this almost always results in ROI. The drone implementation across the spectrum of local government has continued to result in an ROI, and that's why we're seeing such widespread adoption across the country. We're seeing it used in multiple different ways, from using it in planning and design, progress tracking, definitely inspections, earthworks using volume calculations, and just quality control on different improvement projects. County governments are using it in parcel mapping and land records and change detection. Firefighting organizations are using it for mapping the progression of wildfires and regular house fires. Law enforcement for fugitive apprehension, missing persons, and surveillance. And so before we go into how to convert drone data into information products, it's important to understand the data itself. And so let's talk just a little bit about remote sensing and how we derive information, surface information using a drone. There's two main things that we'll focus on: photogrammetry and LiDAR. Photogrammetry uses photographs to make measurements, as in the name, and LiDAR, which is short for light detection and ranging, uses light, aka lasers, to take those measurements. Both LiDAR and photogrammetry are highly accurate for surveying buildings, infrastructure, and raw land. LiDAR can collect more detailed, in-depth information than photogrammetry. However, photogrammetry includes detailed visualization information on the environment that, in some cases, is indispensable for researchers. This slide shows the difference between LiDAR and photogrammetry, at least how it's captured. Photogrammetry, pictured on the left, uses the telemetry of the drone, GPS in that drone, and the overlap of images to configure triangulation of imagery and make its calculations on elevations. However, LiDAR uses the telemetry of the drone, GPS in the drone, but instead of using the photos, it uses the calculations based on the time it takes the light to leave a sensor and return to the sensor. Using that as well as triangulation helps make measurements with LiDAR. Now, in this image, we're talking about photogrammetry overlap and what we mean when we say photogrammetry overlap. The more triangulations that can be seen in multiple photos, the more accurate the products that you derive can be. So having the adequate amount of overlap in a photogrammetry workflow is imperative to the quality of the data that you're going to get out of that photogrammetry project. When planning that flight, that overlap kist has to set right there in the center. Not enough overlap, you're not going to get enough triangulation, you're not going to get enough resolution. Excessive overlap, it's just going to take the program way too long to process that data, and it's not necessary. You're not necessarily going to get a better product because you have, way in excess of what you need for overlap. If you can hit in that 75 to 80% range of overlap, you're going to get a good information product. This image here is what we see here is a LiDAR point cloud. And I use this image to see how a laser or the sensor can see the pulses go through and penetrate things like a loose tree canopy This allows reflections to come back off of like the roof line and the ground underneath the tree. And this is the main difference between LiDAR and photogrammetry. LiDAR can penetrate sometimes that loose tree canopy, where photogrammetry is going to reflect just off of what it can see. And it's worth noting that, results are not always 100%. Sometimes if a tree canopy is too dense, the laser is not going to penetrate and get the reflections from below. In this image here, we can see a processed photogrammetry project in Dubuque, Iowa. This flight was taken with a camera drone. It's pointed straight down, what we call nadir. And the results are creating a model that you see here. So these 3D models can be created using photogrammetry, but you can only see the tops of the trees. If you pan down and pan around, you can see that there's gaps underneath the trees from the photogrammatical process because the photo can't penetrate those canopies. So this is where you can see differences in information products. And depending on the flight captured, you can improve those products. Now, if there was extra flight done with angles and stuff like that, you wouldn't see these gaps. This is just what you'd see resulting from a straight down shot. Now, when it comes to drone collections at Esri, we offer two main products based on photogrammetry collection. The first product that you may be familiar with is called ARCGIS Drone-to-Map. Drone-to-Map is an on-premise image processing application, and it's great for situations where processing needs to be done either on-site or in a disconnected environment. The second one you see on the screen here, and the one we're going to focus on today, is called SiteScan for ArcGIS. SiteScan for ArcGIS is a cloud-based imagery processing application with flight and fleet management and a multitude of in-app analytical capabilities, as well as a direct connection to ArcGIS Online, ArcGIS Enterprise Portal, and even Autodesk. SiteScan for ArcGIS delivers accurate 2D, 2.5D, and 3D data outputs in a multitude of formats, from orthomosaics to digital elevation models, 3D point clouds and meshes, oriented oblique imagery, as well as thermal orthomosaics, and high-resolution 360-degree panoramic photos. All of these products can meet the varying needs of organizations. And we built SiteScan to be a complete solution for your drone data capture and fleet management, as well as processing. And management and analysis of the data is, in essence, GIS. So what we've made is, in our words, a complete drone platform that leverages your existing investment into Esri. And when we talk about the end-to-end process for conversion of drone information into imagery, that workflow can be broken down into three simple steps. The first is the plan and capture step. This is performed by SiteScan Flight app. Using the app, users can create a flight plan that's relevant to the type, site, or asset being captured. The iPad connects directly to most commonly used drones and sends the flight plans to autopilot for execution. After the flight completes, the images are then transferred over to the iPad and uploaded to the cloud via mobile or Wi-Fi connection. Next, images are processed in the cloud and data outputs are generated. When this process is complete, the user gets an email letting them know the results are available to be viewed in the web browser. In this web app, the user can not only view the data, but also perform some analysis, measuring in both 2D and 3D volumetrics, PDF inspection reports, and/or analyze change detection right in the browser. And for the third and final step, it's dissemination and collaboration. For those advanced analytics or workflows that can't be done in a browser, it's easy to either download the files locally to your computer or publish the data sets directly to ArcGIS Online or your enterprise portal. And like I said earlier, SiteScan is a one-step drone platform that leverages your existing investment into Esri. However, it also leverages your existing investment into Autodesk as well. If you have an Autodesk workflow, you can also publish directly to your BIM 360 cloud from SiteScan or use the ArcGIS Autodesk connectors. So let's take a look at these steps a little bit more in detail, but first we need to talk about compatibility. There are a lot of drones out there on the market. You can find this list by Googling SiteScan for ArcGIS compatible drones. There you'll find an Esri community post with this matrix. And while we at Esri are constantly working on expanding this list, there are a few key things I want you to know about compatibility. First, if your drone's not on this list, it doesn't mean you can't use SiteScan for ArcGIS. This simply means that SiteScan Flight app may not be able to be used, As long as your drone imagery is georeferenced, meaning that the sensor, the GPS information are all in what we call the XREF of the image, you can acquire, and you've acquired adequate overlap of your images, SiteScan Manager app can still process that information into that imagery into an information product. And in the following slide, I'll show you what I mean by XREF data. So the SiteScan Flight Planning app is an iOS tablet application only. So if you have a smart controller, those are typically Android based and the app's not available yet. I know development teams are working on this, but currently iOS tablet application only to control the drone with the SiteScan Flight Planning app. And third, we're always working to expand the platform, and there's been some integrations recently for SiteScan Flight Planning app that are already being accomplished and are being fine-tuned, such as using the drone to map from the sky using Quick Capture. This compatibility is open to a multitude of use cases. Quick Capture is a rapid data collection app, and typically Quick Capture allows the user to collect a point or a line using GPS of a mobile device connected to a GNSS. We've now been able to use Quick Capture to collect X, Y of the drone, not of the controller. So this would allow you to say in like a search and rescue mission or fugitive apprehension mission to fly over and mark the location of the object of interest from the sky. The drone doesn't have to hover over the people on the ground and try to see the people on the ground, try to see the drone through the tree canopy or whatever obstructions. This alleviates the issue of like a low battery, like not being able to stay in the same location. And if you have a feature layer in a connected environment, you're using Quick Capture and you configured field maps to read that feature layer. In a connected environment, the people on the ground would have real-time data at their hand, so they could just use the compass tool and navigate directly to that POI. So there's a lot of different functionalities when you're using the SiteScan Flight Planning app. If you haven't purchased a drone, I highly recommend getting one that's recommended on the drone site if you're looking to use the full capability as we develop and move forward. Now I'll show you what I meant by XREF data. So you can see here in the file browser, I can see pictures from the flight. If I click on the image and right click and go to properties, once there, the properties, click on details, I can see the back-end XREF data associated with the image. This data is what allows the photogrammetry process to happen. So if I have all the latitude, longitude, altitude, the photo sensor information, I can usually process that information. So let's talk a little bit about flight planning app functionality. So the SiteScan Flight Planning app, like I said before, it's an iOS application. It's cloud connected. It makes automating your mapping missions simple. It allows you to collect the information from the field as well as do field data management workflows, fleet management, and also set up organization-wide mandated custom pre-flight checklists and forms. The app being connected to SiteScan Cloud allows you to save and share flights between project members to ensure like consistent data is captured. Additionally, this means that your teams are always using the most up-to-date information. So you could use previously captured orthos to automatically plan a flight on top of satellite imagery, so you can have the most up-to-date information. And you can also bring in any type of layer from your ARCGIS Online or your portal into the flight planning app if you need that for planning 3D information also. So this is just another picture of overlap, but this is where we can talk about one of the main functionalities of SiteScan Flight Planning app, which is called Terrain Follow. Terrain Follow actually allows you to stay at consistent elevation above the ground, not just stay at consistent elevation from your starting point. This will eliminate overlap issues when you have a big fluctuation in elevation. So, and other than just avoiding obstacles, this can definitely help with the quality of the product that you collect when it comes to photogrammetry. So while collecting imagery with all the right parameters may seem a little bit complicated, the flight management software that comes with most drones makes it pretty simple. So typically you just select your mission, the type of resolution, your output imagery, draw a box around the area of interest, let the flight management software figure it out. Once the mission's parameters are calculated, the flight management software uplinks information directly to the drone. And once completed, the drone flies back to its point of origin, lands off originally where it took off from, or if it needs a battery change, it will come back. And I understand firsthand, the first time I turned my drone over to an autopilot, it was nerve-wracking. But I'll tell you this much, you get much better results when you let the robot be a robot. And in most cases, drones are getting a lot more cost effective. So they're not as expensive as they once were. Don't let somebody convince you to buy a $20,000 or $30,000 drone. A lot of the stuff you're wanting to do can be done with a simple Mavic Pro, which are around $1,500. We've even done some testing on drones down to $500. So here are just a couple flight plans just to get you an idea of like when you're planning a flight, using the right flight plan so that you can collect the imagery in the right way. The most common is an area survey. We call this a lawnmower pattern. It's the most effective to collect a large area. Most of the time, the imagery is collected with the camera pointed straight down or nadir. The imagery method capture is what we use for most ortho mosaics. But if you have a structure and you're looking to make a 3D model, straight down is not going to catch everything like we saw in the picture of the trees. In this image, we can show what we call melt. On the left is what the drone saw. This is what the drone took a picture of. Whenever it was processed on the right, we got the melt of what was underneath the overhangs. This is the interpretation of the software to let you know what it thinks is under there, but it doesn't know. So having enough images at the right angles and heights on a model becomes increasingly imperative when you're wanting increasingly realistic examples. This example here is actually a 3D model. It's not just a picture. And this is one that a customer captured, and they did it with multiple different angles on a crosshatch survey. And you can see that when you do it that way, you get some distortion in some things like that porta potty in the middle of the cul-de-sac, but mostly you get a realistic image product. So planning the right flight is imperative to what results you're wanting to get. So this is what a crosshatch survey was, which was what was used in that previous picture. That crosshatch plan is taking two perpendicular area surveys together, switching the gimbal angle to a 35-degree for oblique mapping of vertical structures. And this is the best whenever you're trying to cover a lot of area, but you still want a 3D model. Now, if you're wanting something more detailed in a 3D model, you may look for a perimeter scan. So a perimeter scan is going to allow you to do a multi-tiered flight around an object of interest. Define a polygon that you want to capture. Maybe it's a structure, maybe it's a compound. Or a subdivision. You may want to combine a couple of these flights so that you can get a really good 3D model. So just take these different flight plans into consideration because there's many of them. And the next ones we're going to go through kind of quick. A vertical scan. If you wanted to just scan one side or one face of a structure, or in this case, the stadium seats at a football stadium, this may be an option for you. If you're looking to do a corridor, so a road or a utility easement, this was designed to help organizations when the FAA had issues with flying over vehicles. Check with the FAA for current regulations and laws. They've been changing them so frequently, I haven't kept up on it. And I haven't really had time to fly, so I haven't had a need to. But quarter scan can be a great way to capture an area without not flying over the area. And also, if you needed to fly over the area, you could do that as well. But it's a really easy way to define a longer area. And hopefully you have a BVLOS or beyond visual line of sight waiver from the FAA. You can do a lot of area without having to also follow the drone. The next one, this is not alien mode. This is panorama mode, but the graphic that they made looks like it's an alien spaceship there. So a lot of people thought that was pretty interesting. This is where we could get a panoramic 360-degree photo. This define a location, a height, the drone flies up, takes multiple photos at a certain elevation, stitches them all together, and gives you a situational awareness shot. A lot of people include these in a flight plane just so they can have a situational shot in conjunction or separate from their actual model that they're creating or their flight plan that they've created. And there is no photogrammetrical process or information product created natively from inspection workflows. But this is one of the main reasons a lot of organizations buy drones. Being able to get up to an area that you don't want to put a human and being able to fly in real close, inspect information or expect things and see what's going on. Just be sure not to fly the drone into the water stream or it may not stay in the air. So now we're going to go into a quick demo. I'm going to actually show you the SiteScan flight planning app using terrain follow. Here in the office, we're planning a flight to capture an updated 3D model of a dam in Northern California. Using the area survey flight mode, we simply trace out the boundary of the area we're interested in and enable terrain follow. The pilot can preview the flight plan in 3D. The pilot's also provided with estimated flight time, resolution, number of batteries required to complete the mission based on the type of drone being used. And as you can see that all at the bottom of the screen. The flight plan can be saved for future use for a different pilot to go over and execute in the field. And if the flight will be conducted in an area without cell phone coverage, an offline base map can be downloaded as well. Once on site and connected to the drone, the pilot will retrieve the saved flight plan. And after performing an initial review of the flight plan, the pilot will be prompted to complete the customized pre-flight checklist and record the organization's mandated items, such as the name of the visual observer and additional safety briefing can be provided after the pilot's reviewed all this information in the app. After looking at the additional safety briefing, the pilot will check off on it. The drone will provide its automated check of everything on the drone, and then it's off. Once it's up in the air, the drone will continue the flight plan. There's many different ways to observe this as it's going through the sky. 3D mode, 2D mode, flight plan mode. Once all this is done and it's completed everything, it returns directly back to its landing place. And now the images can be transferred over to the iPad, either wirelessly or through an SD card. Once you've looked at all these photos and determined that they're all good and uploaded them into SiteScan Manager, it's on to step 2, the process step of the drone capture workflow. So now that we've completed the data capture, we're on to discuss process, manage, and analyze step. That's step 2 in the drone workflow. And this all happens in SiteScan Manager Cloud. SiteScan Manager is a web application that allows the user complete control of the data they've collected by the drone and provides an easy access point for people to visualize and analyze the data. One benefit of the cloud-based application is that almost everything is immediately available across your organization. No need to download massive files. We've designed SiteScan to be accessible to all your team members, even the less tech-savvy ones. And the web interface offers 2D and 3D viewers and a variety of analytical tools that allow your team to perform a majority of the common tasks that one would want to do with drone data. Overlays, measurements, reports, annotations, or just sharing with colleagues all can be done with little or no training at all. And to make your drone imagery truly valuable, beyond providing up-to-date view of the site or inspection photos, it's critical that your team trusts the accuracy of the data outputs. And this is why we built in tools to make it easy to tie your data to surveyed ground control points. The association of your imagery with these ground control points, or what we call GCPs, can be done through an assisted or manual workflow. Or it can be fully automated through computer vision detection of your ground targets. The processed outputs will be delivered to your project in your project's coordinate system, whether it's a known or a local coordinate system. And to measure and validate the accuracy of your results, independent checkpoints can be used, and a detailed processing report is delivered for every flight to assess the quality of the processing. For those of you wanting to use an RTK or PPK enabled drone, such as the Phantom 4 RTK, SiteScan also makes use of the enhanced geolocation accuracies of those images to provide higher accuracy outputs, whether or not GCPs are being used. Now let's take a look at SiteScan Manager web app. Now that I've logged into SiteScan Manager account through my standard web browser, I can view the projects I have access to on the map or view it in list view. Here on my list is the San Pablo Dam project, I can see 2 missions have been completed on this, including the one we just saw being captured. For this mission, results took about an hour and a half to process. I can view my photos and the updated orthomosaic. I can display elevation data in either a heat map and or contours. And I can use this timeline tool to look for change issues from a previous flight in 2017. I can view the point cloud that was collected without any need to download any data. There's several tools available in here where I can measure height and generate a profile view of the site. And down here on the left, we can see the export menu. This allows me to download all the raw outputs in common file formats, generate a link to share data with colleagues, or publish the data to ArcGIS Online in just a few clicks. Now we'll jump over to a completely different project. This one's actually in Japan, where there's a new water reservoir being built. I can give you a quick tour of the site using the 3D mesh viewer. So here we're looking to gain insights on ongoing earthworks. The project manager has uploaded 3D grading surfaces, which can be compared against our drone data to generate a cut fill heat map. The user can define ranges to display the data that suits their team's need and elevation deltas. Or volumes can be displayed on the map in grid format for more detailed quantification of a specific area. We can use the volume tool and trace out a boundary and display that area in 3D. Choose the comparison surface to get detailed cut and fill value in seconds. This is a process that would normally take a trained CAD user 10 to 15 minutes to complete, not including data download time. It can now be done in just a few seconds by virtually anyone. Or coverage area just by clicking and dragging the points. And you can compare it against the base. Personally completed back in 2030. I wanted to show elevation. The water in the pit to the east, higher or lower than the pit to the west. If I would have had this tool at my disposal back then, I could have answered the question in a few left. 83. These are simple ways to do analytics. We can see down here in the bottom a section of the point cloud, not the whole point cloud. And we could have used, we're going to look at the elevation profile tool against this to analyze that the bottom is lower than the top of the water. Now using the volume tool, I'm going to draw a volume area around anything in the capture area. This is going to cut it off at a flat plane with everything else surrounding and be able to now analyze stockpile volume calculations almost instantaneously. One more flight I'm going to look at is this electric transmission easement. Using this electric transmission easement, we're going to look at the photo inspect tool. You can see there's 510 photos and there's been a orbit around these towers up on the north end. If I zoom in, I know there's a lot of photos in this area. If I use the photo inspect tool, click on one area, it's going to bring up every photo that was encompassed by that area in an interface where I can look through it. Now I have 55 photos of that exact same point that I can go through and look at from different angles. A really good tool, separate from the video inspection process. You can use a photogrammatical process. And one last one I want to look at here is a thermal orthomosaic. We used to only be able to look at thermal imagery at a glance while in flight. Now we can map it. Mapping it inside a site scan allows you to do analytics on the imagery, just like you would that elevation information. Being that there's 1,249 photos or 1,294 photos because of the thermal, it takes a little bit to upload, but once it uploads, we have a lot of different tools in here. So we can make it a little see-through, we can turn on the ortho underneath, we can run the temperature range down to really highlight the heat points. And this allows us to really see where the hot points are in this flight, not just looking at it at a glance while it's in the air. So that was the flight manager. So I want to look at fleet management capabilities in SiteScan Flight Manager. So another component of it is the fleet capabilities. SiteScan contains the ability to manage your fleet. If you have more than one drone, this is imperative to keep record of your peripheral equipment, your batteries, make sure that everything's being used equally. You have a record of maintenance, and in the event of an issue, it proves invaluable, determining that you had done your precautionary measures and taken every step possible to ensure safe operations. All the different parameters are here so that you can see if your pilots or your equipment needs to be cycled. There's a lot of different capabilities inside of here, and this is one capability that a lot of image processing softwares do not include in their program. So let's discuss that final step, that third step of the drone data workflow: disseminate and collaborate. You can simply download the information for local use, but you could also conduct advanced analysis by leveraging ARCGIS platform. You can use ARCGIS Pro, for example, and also use that to do artificial intelligence workflows, which we're going to show here in the future. But before we get to that, I want to talk a little bit more about our new Sure engine. So the Sure 3D Mesh engine is the highest resolution imagery engine in the market. And you can see the blur in the red circle on the top compared to the refinedness on the bottom. This is not just a picture. This is a 3D mesh that was generated from multiple pictures. We now have the capability to process 3D meshes at a resolution never achieved before. So this is a really powerful tool. This is a quick demonstration of using Quick Capture with the flight planning app, being able to mark out a boundary as you're flying, select hotspots. This just shows you just a little bit of a quick analysis of that capabilities of using Quick Capture and mapping from the sky. And last but not least, I want to show an example of an inspection process on a dashboard with some site scan data. This ArcGIS dashboard incorporates a 3D scene with drone products, meshes, and on the right-hand side, you can see different status updates and a 2D map as well. But you can also see where we have features for different inspection processes that need to be done, and a way to analyze this all with Revit data and BIM data. So it helps really give a situational viewpoint from the drone, the 3D model, and BIM to be able to see the full picture. So, and this is all displayed in a dashboard. So now we're going to get on to GeoAI, specifically deep learning and feature extraction. First thing I need to note is that AI is not just one product. It spans the entire ArcGIS platform. So there's not one app or software or desktop component this is our artificial intelligence app or product. This is kind of baked into a lot of different aspects, and it's all designed to enrich your GIS. Some terminology, what is artificial intelligence? It's the idea of achieving human level intelligence. Machine learning is a field within AI that's all about learning from the data to derive rules and extract patterns. And deep learning is one type of machine learning that's become very good at extracting patterns from highly unstructured data like voice, images, and text. So usually when a GIS person says AI, they really mean machine learning. There are 5 major patterns in machine learning, and the one we'll focus on today is extracting features from imagery and LiDAR. The imagery deep learning tools enable an end-to-end workflow that can help with managing, storing, pre-processing imagery, and also help with labeling, which is needed if you want to train a deep learning model for object detection or pixel classification. You can also export training data in the format that's required to train models. The advantage of doing this all in ArcGIS is that your work doesn't stop here. You can use the different spatial analytical tools on top of your output to perform more insight and to derive different models from this information to answer bigger questions. You can also use maps and apps and dashboards to disseminate the information and to share it with others. This can be done with a wide range of data types: aerial imagery, satellite imagery, radar, LiDAR, motion imagery, bathymetry, and even more. So here are a few examples of projects we've been working on, like detecting damaged structures and roads for public safety scenarios. This can be helpful when responding to disasters to understand the impact and the extent of the damage and to prioritize rescue operations. We can see that the automation of the map production is the major theme here as well. Examples including detecting building footprints, land cover, road segments. These are all examples of automatically extracting features from imagery to build or update vector maps. You can also see scenarios like crop detection and health assessment for crops, assessing the health of palm trees, combining deep learning and spatial analytics for departments of transportation and local governments. And we've seen scenarios like road crack detection. If you're thinking, well, I've been doing some of this work for decades, you're not wrong. The GIS and computer science communities have only recently started acknowledging some of these types of workflows and seeing that they are truly a digital image or machine learning process that can be automated. And to bring it full circle, we have created here at Esri ready to use models inside of ArcGIS Living Atlas that can save you a lot of time. Instead of preparing and training data and training models from scratch, you can use these ready to use models for your workflows. They're well trained for different data sets and scenarios, but they can also be retrained. You can also retrain the models for your local data. So if you need to increase the accuracy, you can take this data flow or this data model and you can improve on it. So ArcGIS Living Atlas has a lot of models for common workflows like identifying building footprints, road segments, land cover, human settlements, swimming pools, solar panels, pavement crack detection, wind turbine detection, and more. And you can use these models inside of ArcGIS Pro, ArcGIS Online, or ArcGIS Enterprise. Image Analyst extension is required at Pro, using it in image server in Enterprise, and ArcGIS Image and ArcGIS Online. Here, we're using a 6-inch image service from Kentucky from above. Let's imagine that this is an area of new construction and we need to create building footprints to add to the countywide layer. I can use the Imagery Analyst extension in the Deep Learning Toolbox to detect objects, and only inputs I'm responsible for are the raster data set, the name for my output, and the model definition. Finding it inside the Living Atlas is simple. Searching for DLPK in Living Atlas brings up all the different deep learning models. Here we're going to use building footprint extraction. There's also tree point classification, pool detection, shipwreck if you need that. But once the arguments are authenticated, you just hit run. But to save time, I'm going to go over here and open what was generated. So these inference buildings, you can see they're not quite square, right? They're a little rounded. There's another tool called regularized building footprints. putting in the inference buildings, putting in the tolerances and right angle methods will square those up. And now there you are, building footprints extracted directly from the imagery. Now these aren't perfect. Don't think they are, because they can need some work. Sometimes you'll pick up a pool or an outbuilding or a trailer. But in general, this can save hundreds, if not thousands of hours, depending on how big your organization and what you're actually trying to accomplish in digitizing building footprints. Well, that right there is basically where I want to wrap up the webinar. And I know I covered a lot of this in a very short amount of time. But if you have any questions, I don't want you to hesitate to reach out. You can find me on LinkedIn. My email address is just first initial, last name at Esri. I'd love to help you with your workflows and try to figure that stuff out. But I am going to stop it right there and stop sharing and look for questions.
Awesome. Thank you, Chase.
Mm-hmm.
Does anyone have any questions? I don't see any in the chat right now.
Matt is an account manager here at Esri, and he said the unmarshmallow tool, my footprints tool.